Okay, hello, good morning. Okay, hello everyone, my name is Tiger. So I'm currently studying in National University of Singapore, and I am taking the course called Foundations for Econometrics. EC2303 is the code. So in this week's lecture, I learned a very interesting inequality that's called Chebyshev's inequality, and I want to prove it to all of you. So what is the inequality about? So Chebyshev says for every random variable x, its absolute value being greater than a positive value epsilon, this probability is always less than or equal to the expectation of x squared over epsilon squared. Perhaps at this stage, me and you are not able to interpret this inequality. How does it help to a problem in real world or in a statistics problem? But we can have a first try to prove this inequality, and maybe in the next video I will show you how useful it is. Okay, so let's now review some concepts. Firstly, probability of x being greater than epsilon is what? It is using integral. So we are assuming that this is a continuous random variable. So the probability x greater than epsilon, it must be use integral to do this. Actually, it's a kind of CDF of x. So how do we write integral? So epsilon at the bottom, positive infinity at the top. Okay, then next we have f of x dx, right? Secondly, what is expectation of square? Expectation of square is from negative infinity to infinity x squared times f of x dx. Okay, so knowing these two concepts, we can better understand this inequality and try to find a proof, So here, let's begin in the left hand side. What is this one? How do we calculate? So we split them apart in two parts, right? So first part is probability of x being greater than epsilon plus probability of x being less than minus epsilon. Be careful with this part, right? Then it is equal to, like I just wrote here, epsilon infinity f of x dx, and plus, how to write this one? So it is the integration from negative infinity to minus epsilon, still fx dx. Now, many of us don't know how to proceed, right? We don't know, but let me introduce a useful trick. The useful trick is to introduce x squared over epsilon squared. So why we are introducing this one? Because here and here, and their relationship, one is the top, one is the bottom. So maybe after I complete the proof, we can have a look back at home, so you will understand why we are doing this. So let's continue. By introducing this proof, this thing, we know that this one is always greater than 1. It's greater than 1 when x is greater than epsilon, right? Also, when x less than minus epsilon, this thing is still greater than 1. So now we plug in. How do we plug in? We say this one is always less than or equal to x squared epsilon squared times f of x dx plus integration from negative infinity to minus epsilon x squared epsilon squared f of x dx. So now you can roughly see why we're doing this, because we want to create an inequality, and this is the best choice we have. Now we are almost there. We're almost there. We're missing one term. So expectation should be the whole range of this x from negative infinity to infinity. So now we're missing a term. What am I missing? Great. We are missing this one. We plus from negative epsilon to positive epsilon x squared epsilon over epsilon squared times f of x dx. But if I plus this one, can we still say this inequality holds? Well, definitely, because this thing is it's a positive number. So if say 1 is less than or equal to 2, then 1 is definitely less than or equal to 2 plus 1 or 2 plus 3.1, right? So yes, so this inequality still holds. Now, finally, we can arrive at a conclusion here to complete the proof. So this whole thing is expectation of x squared over epsilon squared. Because epsilon squared is just a number, so we take them out. 1 over epsilon squared times expectation of x squared. Oh, sorry, I need to write equal here. So now, let me use a different color to help you analyze this one. So from this left-hand side guy, we know that this guy is equal to these two guys. And we did some expansion, sort of an expansion, to get the one with the integral. And then we introduce an interesting guy here, and it creates an inequality for us, which helps us to complete the proof. Then we need to plus in one term here, because with our original terms we cannot make the expectation unless we put a new term here. but this won't affect our inequality. Our inequality still holds. So now this whole term is the expectation of x squared over epsilon squared, and we take epsilon squared out. Now this one is exactly the right hand side. So now we have proved the Chebyshev's inequality. So if you are interested, you can also look at maybe his student called Markov. He also has an inequality, which can be proved using a similar technique as Chebyshev. So if you like to try, you can Google it, and maybe you can let me know after you finish the proof. So yeah, so that's all for today. We proved Chebyshev's inequality. I hope you enjoyed it, and in the next video